Hello students, I'm Dr. Akanksha Srivastava, Associate Professor, School of Management, BBDU University, Lucknow. And in this video, the topic which I will cover, that is data communication and networking. And it is in the third module of the course MIS and e-commerce, and the course code is BBA 3502. So let's start with the topic. First of all, communication medium. What do we understand by communication medium? Communication can be transmitted through wired and wireless medium. Medium is basically the mode, how we are communicating. So we can communicate in two ways, wired or wireless. Wired communication uses physical cables to transmit data, while wireless communication uses radio waves to transmit data over the air without the needs for cables. So in wired communication, we need physical cables, and in wireless communication, we do not need any kind of physical cable. There are certain advantages and disadvantages of wired communication. Like wired communication is generally more reliable, secure, and stable compared to wireless communication. There's one disadvantage of wired communication is wired communication requires physical cables which can be cumbersome to install and maintain. Alright? Yes, we use wires in wired communication. We use physical wires. Certainly these are more reliable, secure, but at the same time it is very difficult to install and maintain it because it includes physical wires for communication. Now wireless communication, where we do not use physical wires. So wireless communication provides mobility and flexibility as devices can connect without being physically wired. This is one merit or advantage of wireless communication. Let's talk about the demerit. Wireless communication is more susceptible to interferences, signal degradation, and security vulnerabilities. So these are certain demerits or disadvantages of wireless communication. Where we can use wireless communication, certainly in mobile devices, IoTs, that is Internet of Things, and smart homes. Any smart device, there we are using wireless communication. Nowadays, in most of the things, we are using wireless communication. Now, let's talk about the mode of communication. So in computer network, we can use different communication modes. It can be simplex, duplex, or half duplex. Actually, these modes determine the direction and flow of data. How the data will flow and how it will transfer between the devices. All this we decide with the help of what kind of mode we are using for communication. Simplex or duplex or half duplex. Let's see about these modes. The simplex communication is a one-way data flow. That means in simplex communication, data flows in only one direction, from the sender to receiver. For example, radio, television broadcast, where information only flows from the station to the receiver. That means receiver cannot send back anything. Only sender will send. So simplex is suitable for unidirectional data transfer, such as monitoring and alert system. There is only one way data flow, that is what? Simplex communication. The second one is duplex communication. We can call it bidirectional data flow also. In duplex communication, it allows data to flow in both directions simultaneously. At the same time, sender and receiver both can send the data. We can call it full duplex also because both the parties can send and receive data at the same time. For example, telephone. Next one is half duplex. Data can flow in both directions but not simultaneously, like a walkie-talkie. If sender is sending, then receiver cannot send, and if receiver is sending, then sender cannot send. Only one party can send. Data will flow in one direction at a time, right? This is what half duplex. Try to understand it more. The basic properties of half duplex communication, number one, it is unidirectional. Actually, data can flow in both the directions. Why I am calling it unidirectional? Because at one time, the data can flow only in one directional. That's why I am calling it unidirectional. Next is sequential. The communicating devices can turn sending and receiving data. For example, walkie-talkies, where users press a button to talk and then release that button to listen. So this is all about half duplex. A simple comparison I have drafted. You can see it, simplex, full duplex and half duplex. I hope it is clear. Now, the networking. So first of all, we need to understand what is networking. Networking is the foundation of modern digital communication and connectivity. It encompasses the systems, technologies and protocols that enable the exchange of information between devices and users across local, metropolitan and wide area networks. This introduction will provide an overview of key networking concepts, including local area networks, LANs, metropolitan area networks, MANs, and wide area networks, WANs, as well as common network topologies and switching methods. Understanding these fundamental aspects of networking is crucial for effective navigating the digital landscape and leveraging the power of interconnected systems. Right. So there are few networking concepts. Number one, device and protocol. Number two, addressing and routing. And number three, bandwidth and throughput. Now what it is? Let's try to understand this. Network, what is devices and protocols? Networking involves the seamless interaction of various devices such as computers, smartphones and servers using standardized communication protocols like TCP and IP, Ethernet and Wi-Fi. These protocols define the rules and procedures for data exchange, ensuring compatible and reliable connections. Addressing and routing. Each device connected to a network is assigned a unique address, allowing for the identification and routing of data packets. This addressing system coupled with routing mechanism enable the efficient transfer of information between endpoints across complex network infrastructures. And the last one is bandwidth and throughput. Bandwidth refers to the maximum amount of data that can be transmitted over a network connection, while throughput measures the actual rate of successful data transfer. I hope this is clear what is bandwidth and what is throughput. Understanding these concepts is crucial for selecting and optimizing network technologies to meet specific performance requirements. Now, the local area network. A local area network is a computer network that interacts devices within a limited geographical area, such as a home, office, or school. The basic key feature is It operates at high speed, utilizing Ethernet or Wi-Fi technologies. You can read out the applications. These are very easy. Next is metropolitan area network. A metropolitan area network is a computer network that spans a larger geographical area, typically covering a city or a metropolitan region. MANs interconnect multiple LANs and provide connectivity over a broader geographical area. Certain features like technology and infrastructure. So MAN often utilizes high-speed fiber optic backbones, leased lines, or wireless technologies. MANs are commonly used by local governments, educational institutions, and businesses to connect multiple sites. Scalability and flexibility, if we talk about these things, MANs are designed to be scalable, allowing for the seamless expansion of the network infrastructure as the needs of the metropolitan area grow. So we can easily, scale metropolitan area network. These are very flexible. Now the last one, this is wide area network. A wide area network is a computer network that spans a large geographical area, often crossing regional or national boundaries. WAN are designed to interconnect multiple LANs and MANs, enabling communication and resource sharing over vast distances. Let's talk about connectivity and technologies. WANs typically utilize a variety of high-speed communication technologies such as leased lines, satellite links, and dedicated fiber optic connections to provide reliable and efficient data transmission across the wide area network infrastructure. What are the applications and uses? WANs are widely used by organizations, governments, and service providers to connect geographically dispersed offices, branches, locations, and data centers. They enable seamless collaboration, centralized data management, and remote access to shared resources, supporting the needs of large-scale operations and global enterprises. So this was about LAN, MAN, and WAN. I hope this is clear. Now there are certain network topologies. First of all, we need to understand what is a topology. Network topologies refers to the physical and logical arrangements. Basically, these are the physical and logical arrangements of interconnected devices within a network. The choice of network topology affects the performance, scalability, and resilience of the overall network infrastructure. It is basically the physical and logical arrangement of interconnected devices within a network, and this is known as network topology. And what are the factors through which we can select that what kind of topology we should use as per our requirement? The selection of a network topology is influenced by factors such as size and geographical distribution of the network, the required level of reliability and redundancy, and the available resources, and of course, last but not least, budget. If your pocket allows, you can go any kind of topology. Okay. The very first, bus topology. In a bus topology, all devices are connected to a single shared communication medium, typically a backbone cable. There is a unidirectional data flow. It is accessible to all. And one very important thing is single point of failure. The shared nature of the bus topology means that a failure in the backbone cable can disrupt the entire network. If there is error in single system or a single wire, the entire topology will not work. This is what bus topology. Next is your star topology. In a star topology, all devices are connected to a central hub or switch which act as the coordinator for data transmission and reception. Each device has a dedicated connection to the central hub, as you can see in the diagram also, allowing for more reliable and efficient data flow compared to the bus topology. The star topology is highly scalable as the addition of new devices does not affect the existing connections. It also provides a higher degree of fault isolation as a single device failure does not disrupt the entire network, which was the case in bus topology. This is not the case in star topology. Next is ring topology. Continuous loop. In a ring topology, devices are connected in a continuous loop with data traveling in a unidirectional manner around the ring, as you can see in the diagram also. Communication is managed through a token, a special data frame that is passed sequentially from one device to next, granting the right to transmit the data. Step by step, the data will flow. The third one is resilience and fault tolerance. The ring topology offers a degree of resilience as data can still be transmitted in the opposite direction in the event of a single link failure. I hope this ring topology is clear. Now we are reaching to the end of this presentation, types of switching. So before I'll discuss types of switching, we need to understand what is a switch. Switch is basically a device which connects various networks. It is a physical device which connects various networks. So there are different types of switching like circuit switching, packet switching, hybrid switching. Let's discuss them one by one. Circuit switching establishes a dedicated communication path between two devices, reserving the entire bandwidth for the duration of the connection. This approach is commonly used in traditional telephone networks and is designed to provide reliable and consistent data transmission. Next is packet switching. It divides data into smaller units called packets, which are then transmitted independently across the network. Packets can follow different paths and are reassembled at the destination, allowing for more efficient use of network resources and supporting the delivery of data, voice and video communications. And the last one is hybrid switching. Hybrid switching combines the principles of circuit switching and packet switching, leveraging the strength of both approaches. This method is often employed in modern communication network to provide a balance of reliability, efficiency and flexibility in data transmission. So these are various types of switching. I hope this entire video, from the starting we have discussed data communication, then modes of communication, then we have discussed networking, types of network, topologies, types of topologies, and this types of switching. It is clear to all of you, and yes, I will end this presentation here only. Thank you.